Fatty acids are of two types, that is saturated and unsaturated fatty acids. Now saturated fatty acids are those which do not have any double bond in their carbon carbon backbone. So as because they have all single bond, they will have a linear backbone. Whereas unsaturated fatty acids are those which can contain at least minimum one unsaturated minimum one double bond in their carbon backbone, or it can be more than one. So if it has got only one backbone, one double bond in their backbone, so it is a monounsaturated fatty acid. And as we know, that double bond induces a slight bend. So this entire backbone will be slightly bent. There will be a kink at the side of the double bond. So this is the case of monounsaturated fatty acids. But if it is a polyunsaturated fatty acid, that is, it will have more than one double bond, more than one type of double bond. So entire structure will be more bends. There will be more bends and kinks in the backbone. So here we see these are the bent region of formation of double bond. So we see the saturated fatty acids and the unsaturated. These are the unsaturated fatty acids. So saturated fatty acids, they are mostly of animal origins, especially red meat, but certain plant products, for example coconut oil, palm oil, these are also saturated fats. And the unsaturated fats are mostly of plant origin, and they are also found mostly in other fish, marine fishes, and algae, macroalgae. And that is why, and they are, as unsaturated fatty acids are very healthy. So in many countries, especially in South and Southeast Asia, we see that their diet is mostly based on marine algae as a major part of their diet. And this marine algae, they contain omega-3 as well as omega-6 type of fatty acids, that is unsaturated fatty acids, which are very beneficial for our health. Hello friends, I am Dr. Ayantika Das, and in this video I am going to discuss about the various geometric isomer of fatty acids, and also solve a question that is in the previous years of GSET, that is Gujarat Set. I do make videos on botany syllabus of various universities, and at the same time I do make videos on other biology related topics from CSI and NET as well as SET. So in this video I'm going to discuss about the geometric isomer of fatty acids. So this is the question from GSET. Which one of the following statement is incorrect with respect to the nature and properties of lipid? So the first option is that most natural unsaturated lipids are cis isomer. That is cis and trans isomer, they are the geometric isomers of unsaturated fatty acids. So here in this video I will be discussing about saturated, unsaturated fatty acids, as well as the isomers of the unsaturated fatty acids. And then the B option is, that is N3 and N6 denotations of unsaturated fatty acids are based on the last double bond, bonded carbon from the methyl terminal. And the third option, that is the N3 and N6 denotation of unsaturated fatty acids are based on the last double bonded carbon from the carboxyl terminal. That is N3, that is the omega-3, and omega-6 fatty acid denotations, that is we will see how the fatty acids, they are numbered. Their lipid number will be discussed in this video. And then the D option, that is the lipid fluidity, is different for cis and trans. So we will be doing a structural analysis about this cis and trans forms of lipid also and their properties. So let's begin the video. So this is an overview. The saturated fatty acid, as I told in the very first slide, that they do not have any double bond in their carbon chain. So this is the carbon chain and do not have a double bond here. We can have double bond in their other groups also, that is the, but not in this carbon chain. On the other hand, in unsaturated fatty acids, we see there can be one or more than one double bond, and we know that at the site of double bond there will be a kink in the backbone. So this that is why the saturated fatty acids, as they are linear, they can be stacked one over the other, and so that is why this saturated fatty acids, they are solid at normal temperature, and that is why, as because they are solid and they are very stable, and they can be stacked one above the another, so that is why they are chemically also less reactive and structurally also very stable. That is why they have much higher melting point. On the other hand, for unsaturated fatty acid, as because of they have this double bond here, so they cannot be stacked one above the other. So we see that there is a great space between the two layers of unsaturated fatty acid. That is why this type of structure is less stable and chemically also very reactive, and that is why they are liquid. Unsaturated fats are liquid at normal temperature, and they are also very chemically reactive. And this type of fatty acids, because they cannot be stacked one and over the other, they are very structurally unstable, and this type of unsaturation can be for one or more than one type of or more than one position. There can be double bond, that is mono and poly unsaturated fatty acids. Poly will have much more number of double bonds and mono will have just one. But the main thing is that the saturated fatty acid, they are not that much health promoting, because they increases LDL, that is the low density lipoproteins, which are considered as a bad cholesterol, because they lead to all type of cardiovascular diseases. And so that is why not only WHO but also FAO, they have recommended that at any state the consumption of saturated fatty acid should not be more than 10% of the total calorie intake in our body per day. And these are the various sources of saturated fats, like for example margarine, coconut oil, lard and all, meat. So the unsaturated fatty acid also it has got some health promoting benefits, like it increases high density lipoproteins, that is, which is a good cholesterol, and it reduces the LDL, that is the low density lipoprotein, that is a bad cholesterol. That is why it prevents the production of cardiovascular diseases, and also it has got other function like unsaturated fatty acids like omega 3 and omega 6. They produces a variety of enzymes and other proteins that help in the developmental process, that is they improve our body functioning and are very essential for various type of body functioning. That is why unsaturated fatty acids are very much recommended, that is it should be consumed up to 30% per 30% of the total calorie that a person can intake per day. But however, we should not be totally stopping this in our diet. We should not totally stop any type of fat. We should have certain some fat, because first thing, all the vitamins, that is the vitamin, some of the vitamins like vitamin A, vitamin E, K, these are all fat soluble vitamins, and we know that vitamins, they are the cofactor for a various type of enzymatic reaction. So that is why we should have fat in order to absorb this vitamin and make this vitamin bioavailable for us. And at the same time, many of the unsaturated fatty acids, they themselves, they are very much essential for now we going to see about the unsaturated fatty acids. We know that the unsaturated fatty acid, based on the number of double bonds they have, they are categorized into monounsaturated, which will have one double bond, and polyunsaturated, that is, which will have more than one double bond. And this cis and transposition, that I will explain in the next slide. So the monounsaturated fatty acids, they have, as because they have a single double bond, they will have a slight bend only once in their backbone. But in case of polyunsaturated, it will have much more bending, like that it will have a single bend. But in this, depending upon the number of double bonds, it will be bent very much, like this. Some polyunsaturated fatty acids, they are bent like this also. So basically, this monounsaturated fatty acids, they can be somehow, they can be stacked over one another, and they can be semi-solid at room temperature also. But this polyunsaturated fatty acid, as they cannot be stacked over one another, they are like this, so they are usually liquid at room temperature. Both of them are liquid at room temperature, but as the temperature decreases, this type of structure help in making the monounsaturated fat freeze more easily. And if we consider the health benefit, we can say that both poly and monounsaturated fatty acids, they are health promotory, because they reduces the LDL and raises the HDL, that is the good cholesterol is raised, and the bad cholesterol, that is the LDL, it is decreased. So this is health promotory. Olive oil, canola, avocado, these are all monounsaturated fatty acid. On the other hand, the health benefit of polyunsaturated, they have the same effect, that is, they help in reducing the heart diseases, but they have got other health promotory benefits also, like for example the omega 3 and omega 6 fatty acids. They are very much essential in various processes, that is, they not only they are help in multiple developmental processes and various metabolic processes, that is, they themselves are certain cofactors, or certain they form they are very health promotory. They form various intermediaries, these fatty acids. And so the omega 3 to 6 ratio should be very high, because they help not only reducing inflammation, but also they have many other benefits, like they have this anti-anthogenic effect, anti-inflammatory effect, and some anti-prothrombotic effect also. So that is why the omega 3 and omega 6, both these type of fatty acids, they should be consumed. So here I will be talking about the lipid number. So we see that this one here, it is the carboxyl group, that is the carboxyl group of the backbone of the fatty acid. So this is the structural formula of fatty acid, and here this is the methyl terminal and of the backbone of the fatty acid. This is the methyl, methyl terminal. So if we see the carbons, they are numbered from the carboxyl group, that is this one at the carboxyl group will be the first carbon, this is the second carbon, this is the third carbon. So we are, when we are numbering the carbon, we are taking it from carboxyl group and when we are seeing that the number of double bond, they are numbered from the methyl group. So if this is the omega carbon, so this is the omega, this is the omega 1, this is the omega 2, this is the omega 3 and all. So we are seeing that here the double bond, it is considered from the methyl group. From the methyl group, we'll take an example. Here this is the lipid number we are seeing of alpha linolenic acid. We know that alpha linolenic acid is an omega 3 fatty acid, and this is a structural formula here with the carboxyl group here and the methyl group, that is the omega carbon 1 here. So we see that 18 here, 18 is the total number of carbon in the carbon chain, and 3 here is the number of double bond, that is the, this is another one double bond, this is the second double bond, this is the third double bond. So we are seeing that they are having 3 double bonds. So this 3 is the number of double bond, and n minus 3, it is actually not n minus 3, it is n, which can be also interchangeably used for omega dash x. X is the position at which the first double bond is. So when we consider the position of double bond, we will be counting it from omega. So this is omega 1, this is omega 2, and we are having the first double bond at omega 3 position. So it is n dash 3. Same for eicosapentaenoic acid, which is also a omega 3 fatty acid, and also docosahexaenoic acid, DHA, which is also a very important omega 3 fatty acid. So these are the lipid number and structural formula of the omega 3 fatty acids. And these are the these two, this is the prostaglandin, and this is the structural formula of leukotriene. This is the structural formula of leukotriene. So likewise, we can also get the lipid number here. Number, we can also you can just try the lipid number of prostaglandin and leukotriene, and you can write it in the comment section, so that I'll understand how much you understand the topic that I have discussed, that is the lipid number, how to denote a fatty acid by this lipid number. So this was about the omega 3 and omega 6 fatty acid. These are the prostaglandins and leukotrienes. These are omega 6 fatty acid. This is the omega 6 fatty acids. Both are unsaturated cis isomers of fatty acids. So the trans and cis configuration, we know that both the trans and cis, they are geometrical isomers. So in case of double bond, this one, in case of this double bond here, we see that both the hydrogen atom, they are on the same side of the double bond. So then it will be a cis configuration, and if this one is in the opposite side, then it will be a trans configuration. So if in the such type of cis configuration, there will be a slight bend at the site of double bond, but in case of trans configuration, there will not be any such bends, and that is why this cis configuration, this one here, the cis configuration will have the cis configuration as this will have a slight bent structure, so it cannot be so well stuck. In case of trans, they can be stacked over one another. That is why this trans configuration will have a more compact form. They will be compact in structure, that is more stable. They can also be very structurally stable, chemically more inert, and they can have a much, as because of this property they can have much higher melting point, because they can be stacked so closely. They can have a higher melting point in comparison to the cis. The cis, they will have a kink. They will have a kink on their surface, on their backbone, so they cannot be so well stocked, and that is why they are the cis isomer of unsaturated fatty acid will have a much more fluid constitution. They will be less less stable, and they will have a more fluidity, because they are not so well packed, and they that as a result of this nature, that is not so closely stocked, or not so closely packed, they will this cis isomers, they will be they will be having a much lower melting point. So this was what I was discussing in the previous slide, that is about their melting point, about their chemical stability, their thermodynamic stability of the cis and the trans isomer. And this cis isomer, this cis isomer are also very much naturally, they are much more found in the natural form of cis isomer are much more, but the trans isomer, they are not that much common in nature. They are produced by industrially by hydrogenation process, hydrogenation of the cis isomer, so that we get the by this hydrogenation process we get the trans isomer. For example, this elladaic acid, which is obtained by hydrogenation, industrial hydrogenation, and this elladaic acid, which is a trans fat, it is used in frying, it is used in baking and spreads. For example, margarine is also another very good example of trans fat. And in fact, most of the processed food and fast food, they are cooked in this trans fats, and that is why we are always advised not to have those fast foods like burger and all this, because the patty, they are fried in trans fats. So these type of trans fats, they are industrially produced by hydrogenation. Also they can be naturally produced. They are produced naturally by the bacterias that is present in the rumen of ruminants such as cow and buffalo. These ruminants, they have multiple chambered stomach, that is rumen, and in the rumen of this stomach they have this microbial action going on, which is basically this biohydrogenation, and as a result of this biohydrogenation, trans fats are produced. So that is why we see that trans fat. So the about the health related, this trans fat, they are not that much healthy, because they raises the low density lipoprotein as well as very low density lipoprotein concentration. And we know that both VLDL as well as LDL, they are considered as bad cholesterols. These LDL and VLDL, they are considered as bad cholesterols. So as the trans fat, it raises the level of these two, and also at the same time it lowers the high HDL, that is the high density lipoprotein concentration, which is considered as a good fat. This is a good cholesterol. So as the good cholesterol is reduced and the bad cholesterol is increased, so the use of trans fat is totally a no for us. So not only that, it also, this trans fat, their absorption, we know that vitamin A, D, E, and these are all fat soluble vitamins. So for the absorption of these vitamins, fat is needed. But trans fat, if concentration, that is the omega the sorry the cis and the trans fat concentration, if we consider, so we should lower the trans fat, because more amount of trans fat will reduce the absorption of vitamin E in the body. Also, due to this high amount of trans fat, there are many alternation in the genetic expression. One such is that the hepatic expression of certain genes that are that are involved in the lipid synthesis, they are getting increased expression. That is, more genes that are expressing enzymes that are essential in the lipid synthesis are getting expressed. As a result, they will improve the lipid synthesis, that is the fat production in the body, and that is why this is also a very negative impact of the trans fats in our body. So now the question, that is, which of the following statement is incorrect with respect to the nature and properties of the lipid? First is that most natural, here we are going to discuss, we are going to find out the incorrect ones. So the first, the most natural, first option is that A option, most natural unsaturated lipids are cis isomer. So in the previous slide also I discussed that cis isomer are more common than the trans isomer. So they are and the trans isomer, they are produced by hydrogenation, and that hydrogenation generally we are done in we do it in the on industrial scale artificially. Only naturally they are found very commonly in the gut of that is a rumen of ruminants, that is in the we know that the ruminants, they have a chambered stomach, and in the rumen portion there is bacteria that brings about the biohydrogenation, and the trans isomer is formed. So this is a correct statement, this is a true statement. So naturally this is not, as because it is not incorrect, so this will not be our option. Then we see that the N3 and N6, that is omega 3 and omega 6, and N can be used interchangeably for omega. So N3 and N6 denotations of unsaturated fatty acid are based on the last double bond from the methyl terminal. So it will be, we see that this is the methyl terminal here, this is the methyl terminal, and this is the carboxyl terminal. But from the methyl terminal, the first double bond will be, that is N dash X. Here the X is the, here the X position in the lipid number, X is the first position from the methyl terminal. So this is a false statement. They are talking about the last, but we know that this is the first carbon from the methyl terminal that is double bonded. The methyl terminal, this is the methyl terminal, and this, that is the omega 3 position, there is the first double bond. So this is the first double bond will be from the first position, that is closest to the methyl terminal. So the last one, this is the here in the B we are seeing that the last double bonded carbon from the methyl terminal. So this is a false statement. So this will be our option, because they are asking for the incorrect ones. So again we see the third option, that is the N3 N6, that is omega 3 and omega 6 denomination of unsaturated fatty acid are based on the last double bond from the carboxyl terminal. So this is the carboxyl terminal. So the numbering of the carbon atom is from the carboxyl terminal, and the double bond methyl, the double bond is done from the methyl terminal. So this is also a false statement. So this will also be our option, that is the incorrect option. And then we have the lipid fluidity. Lipid fluidity for cis and transforms are different. We know that these are the transforms which cannot be closely stacked, and these are the cis forms, sorry, these are the cis forms that are cannot be closely packed. And about the transforms, so let me draw it here. The transforms, they are linear, so they can be very closely packed. That is why these transforms, which I am denoting by small t, and these are the cis forms which I am denoting as small c. So the transforms, they are much more closely packed, so their fluidity is also less. And this cis forms, they have a higher fluidity. So we see both the trans and the cis forms will have different fluidity, and so this one is a true statement. So this will also not be our option. So we got our answer. So this is basically the structural formula of a certain fatty acids, and I want you to write the lipid number. Write the notation of the lipid number of these lipids that I have shown, and write it in the comment section. This diagram was taken from this research paper, a very good research paper that will improve your concept. You can go to this link and just read the research paper. It's all about omega 3 and 6 fatty acids. So that was all about the isomers of fatty acids and the question. Hope you like this video, and if you like this video, please do hit the like button and do share it with your friends, and do subscribe to my channel to get more such videos. And if you have any comment, if you have any doubt regarding this video or any other video, you can write it in the comment section, and also do write in the comment section about the linking sorry, not the linking number, the lipid number of the various various lipids on the very last slide of this video that I have shown. That way I'll be sure that you have understood the lipid number concept. And I do make videos on various topics on botany and biology. You can go to my channel and watch those videos, and you can also subscribe, because your subscription, you will be getting updates of the latest videos that I make. Thanks again for watching this video.